Okay, so in this video, we're going to be talking about basically congruency and similarity. And so with congruency, what is meant is that we have two shapes are said to be congruent if they are the same shape and size. That is, the corresponding sides of both shapes are the same length and corresponding angles are the same. What does that tell us? It means that, for instance, in this case here, we have 7 centimeters, there will be a 7 centimeters there. These are the two corresponding sides which are equal to each other, just as much as 5 centimeters there is the same as 5 centimeters over there. But also 3 centimeters over there is also the same as 3 centimeters over there. So the shape itself looks the same, and then also the lengths, the sides, the length of the sides are also the same. But also what we actually see is that also the angles are the same, meaning this angle here is supposed to be the same as the one between 7 centimeters and 3 centimeters, which would be over there, right? And as well between 7 and 5 centimeters, 7 and 5 centimeters, this angle is supposed to be the same as that one there. And same thing applies when we look at this angle here. It should be equals to that angle over there. Okay, so basically that is what congruency is, right? It's basically being almost completely the same, right? Being completely the same. So shapes which are of different sizes but which have the same shape are said to be similar. Now that's the difference. So now congruency basically says are the same and also the length are the same. But then with similarity, we say that it's different sizes, but it's the same shape. Okay, so it's the same shape but different sizes. That's what we call similar, right? So the triangle below is similar to the triangles above. Now, as you can see, the length themselves is 3.5 centimeters, 2.5 centimeters, 1.5 centimeters. This is actually smaller than 7 centimeters, 3 and 5 centimeters, right? But the angles inside are the same, and making it the same, if these angles are the same, then therefore these angles inside this triangle will make it into the same shape. So it's the same shape but different size, right? It's a different size. Okay, so basically that is similar and congruency, right? But now let's talk about how do you see congruency, right? There are 4 ways you can see congruency. Prove congruency. When they say prove congruency, what they want you to do is basically say that, okay, in this first triangle compared to the second triangle, I have congruency because it is side, 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 right? Meaning this side is equals to that side, this side is equals to that side, this side is equals to that side as well, right? So you need to be able to identify it and show it, right? So you need 3 reasons, right, to show that it is congruent. So if all 3 sides of one triangle are the same as the length of the sides of the second triangle, then the 2 triangles are congruent, right? And then the reason for congruency in that case would be side, 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 which is the triple S that you can see here. So it's side, side, side. Okay. And then the second way of showing that something is congruent is that when you have a side, an angle, and a side that is the same, then you can have congruency. So if 2 sides of one triangle are the same length as 2 sides of the other triangle, the angle between these 2 sides is the same in both triangles. Then these triangles are congruent. So that is side angle side. And you can see that here, right? We have this length, which is the same as this length, but also this length here is also the same as that length over there. However, they also said something quite interesting. They said that in between these two sides, you would find that angle that's supposed to be equals to the other angle, and that's why you find side angle side. Okay, and that is when you write it in as a reason, you just say it's SAS, right, as side angle side. And then we also have what we call the angle side test, which is basically if 2 angles and the length of one corresponding side are the same in both triangles, then they are congruent. and so there will be angle, angle, and side, right? So if we have two angles, right, two angles and its corresponding side being the same, this side is the same as this side, and this angle here is the same as this angle there, and this angle over there is the same as the angle over there, right? And when you have that, then you also have congruency, right? Angle, angle, side. And then we have the last one, which is a special case where when we have a right angle meaning that it is 90 degrees, we have a 90 degrees, and a hypotenuse and a side, right? A hypotenuse, the longest side, and a side is any possible side that you could have. So if both triangles contain a right angle, meaning you're containing 90 degrees, and we see a 90 degrees with this block that we usually put in between two lines, right? Which also means perpendicular. This also means perpendicular. It's perpendicular, but perpendicular is just means that it's 90 degrees, or you can just draw in that thing there, this block there, which is the right angle, right? And then you have a hypotenuse, which is the longest side, and as you can see, we have the hypotenuse on both sides and the right angle. And then also when you find a length, then that is congruent, and that you'd say is the right hypotenuse side, RHS, right? Okay, so here's a worked example, and with the worked example here, we have ABDF is a square, right? ABDF is a square, and then they also tell us that BC, so where is BC? So BC is equals to FE, right? And then they say find the pairs of congruent triangles in the diagram. So how would we do this? Now we want the pairs of the congruent triangles, right? So we consider first the triangles ABC, right? Where ABC is. So this is ABC. That's the first triangle that we're going to look at. And we compare it to AFE. So this is AFE over there. And as you can see with these two, what can you see? You can see that automatically what they had already given us was that AB, what they've given us, or let's first thing that we can say is that AB, which is that length from A to B, is the same to A and F. Why? Because it is a square, and all sides of a square are equal, right? And therefore, it is a square. And then you also were given that BC and EF are equal, so BC, FE, or EF, doesn't matter the order, but then this is given in the question, and this is given, basically that reason is given. And then you also have what? For a square, one of the properties of a square is that all the angles on the corner are 90 degrees, right? So basically this means it is um has a right angle, right? So if it has a right angle, then what does that mean? It means that angle ABC is equal to angle AFE, which is 90 degrees. They are corners of a square, and corners of a square have 90 degrees, and therefore these triangles ABC and AFE have two sides of the same length and also have the same angle between them. So these triangles are side, angle, side. So basically side, angle, side would be your reason in this case, right? So it's side, angle, side. And then the next pair is that consider ACG and AEG. And AC is equal to AE because the triangle ABC and the triangle AFE are congruent. And then also AG is equal to AG because they are the same length, right? This is common, right? For these two triangles. And then you can also find that there's a 90 degree, which is given in the question. And therefore, the answer for that one is the right hypotenuse side. Okay. So here let's talk more about similarity. Now with similarity, we talk more about size, right? So we're saying it's different size. Similar shapes have the same shape, but may be different sizes, right? So the two rectangles shown below are similar. They have the same shape, but one is smaller than the other, right? And then that's quite clear, right? So they are both rectangles, but these two rectangles actually are similar to each other, but they are non-congruent, right? So they have the same shape but not the same size, as you can see. But now they are similar because they are both rectangles and the sides of them are 3 times larger than the sides of the smaller one, right? And you can see this how do you get from 2 to 3, right? It's 3 times, right? It's because times 3, when you make it bigger, it would be 6. And also times 3 here, then it would be 9, right? So that it has to be 3 times bigger. So basically, this triangle over here is 3 times bigger than the smaller one over there, right? So basically, that would mean that we have enlarged it by 3, right? And it is interesting to compare the area of a rectangle. So the area of a small rectangle is 6 centimeters square, and the area of the larger rectangle is 54, which is actually 9 times, right? Which is just 3 to the power 2 greater, right? So notice 3 times 2 is basically 9, right? But 3 times 2 is the length times breadth, which is the area of this rectangle. But then when you have 9 times 6, that gives us what? It gives us 54, and that 54 centimeters cubic. Basically, if you compare it between the two, it means that you would have said it's 9 times 9, right? It's 9 times bigger than the first one, right? Okay. And so then note that in general, if the lengths of the sides of a shape are increased by a factor of k, um, then the area is increased by a factor of k to the power 2. So this is the interesting thing, right? Notice here that we said at first that this length, the length, just the length, not the area, but just the length, this is 3 times to give us 6, right? And this is 3 times to give us 9, right? However, this 3 times, when we look at area, then how could we see how much it would be enlarged in terms of area? We would say it's 3 to the power 2, which is 9 times. And we did see that it is 9 times the the area, and that's what they basically mean. So basically, whatever number that you increase the length by, you have to you have to raise it to the power 2, and then you'd find what the factor of the increase would be for the area, right? So these two triangles are not similar. The sides of the lengths of the triangles are not the same as the same ratio, so the angles are not similar, right? So as you can see, they are not similar. You can even see with the shapes, they don't look the same. Remember, with similarity, the shapes have to be the same, but then also they also have to follow each other in terms of how big they are, right? Okay, and then for two triangles to be similar, they must have the same internal, right? Internal angles as shown, right? So these are two triangles that are similar, but as you can see, we have 30 degrees, we have 30 degrees, we have 30, 30, we have 100, 100, we have 50 and 50. There has to be there has to be the same angles for both of them. So basically, when you have to prove if something is similar, then you need to show that all three angles in that particular shape, or all the angles in that shape, are the same, right? You have 30 to 30, you have 100 to 100, you have 50 to 50, right? So basically, that's the idea there. So the diagrams below show three similar cubes, right? And these three similar cubes, they are similar because obviously in the case where we look at what similarity means, it means that it's the same shape, right? It's the same shape. All three of them are actually cubes, but then actually, then the only difference is that the sizes of them are different. Okay, so they are still similar, and you can see that this would work out to be 3 to the power 2, and so on and so forth, right? And so here's a worked example. So here's a diagram. So we have the first one and the second one. So the question is that if the area of DEF is 26.46 centimeters cubed, find the lengths of the sides, right? And basically, they actually said the diagrams show two similar triangles. Because they told us that there are two similar triangles, we can use the ideas of similarity to actually find these lengths. So if we use the area of ABC, and we find the area of ABC to be 6 times, right? However, because the area of ABC is the smaller one, that means that it had to be increased to the next one to be a certain factor of the area. So then we put k and then k to the power 2, and then we solve it and then we get 2.1, right? And again, same thing applies. And once we have 2.1, then it's easier for us to multiply each length. So each length, it was 2.1, was it was I mean 5 was 3 and 4, and then we just multiply by 2.1, 2.1, and 2.1, and we get the final answer. So that is the video on congruency and similarity. So again, this is a video, so wherever you did not see, please stop the video and just rewatch it. And if you have questions, please feel free to ask questions. And other than that, I'll see you next time.